Hello, Chair.
Good morning. How are you?
I'm fine, Chair.
Anything to clarify?
No, Chair.
Ready to start?
Yes.
Okay, let us start. Topic 22. Okay, geometric optics. What are the things that you need to remember? Right, we are using U, V, and F positive if the image is real. So for concave mirror, there's your concave mirror. Know how to draw the ray diagram. There's your convex mirror. There's your mirror formula. There's your magnification. Height of image over height of object. Right, remember the key one is R equals to 2F. For convex, image I is always virtual. Upright, right? Always upright. The image is upright. Diminish, always smaller, and form behind the mirror regardless of the position. Right? For this one, convex mirror. So if your U is here, is positive, and then since the image is virtual, V and F is negative. For convex mirror, always remember that. A virtual image cannot be formed on the screen. It's always upright. Right? It's for your mirror, spherical mirror. There's a magnification formula. That is the sign convention that you need to know how to use. And reflection as a spherical surface. For plane surface, absolute reflective index of medium 2. That is your medium 2. Remember the formula, sine I over sine R. Right? Another way of writing is from 1 to 2, sine I over sine R. And reflective index N1 times that angle, theta 1 or I equals to N2 times theta 2. That's a theta 2. This is your for spherical surface. N2 is greater than N1. That's the formula to use. Right? That's your U, that's your V. Then we come to your lenses. That's a formula for your lenses. Lens maker's formula. It's a lens maker's formula. Right? Either one, memorize by either one of them, know how to use it. UC for air N1 is 1. And then remember that R1 and R2, radius of curvature, are large compared to the thickness. Right? And there's a formula for thin lens. Right? Remember, thin lens formula. Right? Same. Right? Real is positive. Convex or focal length is positive. Negative is concave. Okay. Sorry. Right? Sometimes it come out 3 questions. Usually it's 2 only, sorry. Usually it's 2, sometimes 1. Not popular lah. Can't predict anything. At least 1 or 2 questions per year. Can't predict anything here. Right? Most years you will come out at least 1 or 2 questions. Okay. What's the answer for here? An object is 5 cm in front of the concave mirror with radius of curvature 20 cm. Which statement is true about the image formed by the mirror?
A, teacher.
Okay, just imagine in your head how, or you can draw it as your That's your object there. Concave mirror. Calculate your focal length. That's your radius of curvature. Half of focal length is half of radius of curvature. Object is placed less than the focal length. Put in your formula. And calculate that. Okay, good. How about number 2? Radius of curvature of the spherical concave mirror is 30 cm. What are the characteristics of the image
Donkey je.
formed by mirror if an object is placed 30 cm in front of the... Either you memorize it or you work it out, draw it out, the ray diagram. Find your focal length. Since the object is placed more than 2r away, the image is inverted, diminished, and real, and located in front of the mirror. Okay, good, Donkey. A shopkeeper observes a customer through a convex mirror with a radius of curvature 20 meters. What is the actual distance of the customer if the image of the customer is 4.5 meters from the mirror? Yeah.
Donkey.
Donkey also. Right. Find your focal length. Use your lens, your mirror formula. Right. Focal length, remember, is negative because it's a convex mirror. And 1 over u. Right. It's minus because it's virtual. That's your image distance. Okay, Donkey, good. This one a bit challenging lah.
This one I don't know lah.
A sphere is made of material with reflective index 1.5. Contains a small bulk. That's a small bulk there. 1.5 cm from the center. That's the center there. As shown in the diagram below. Given that the radius of curvature, that's your radius of curvature, is 4 cm, what is the position of the image of the bulk as seen by the observer from the left? That's the observer. Okay. So your N1, that's your N1. Right? We call that N1 because that is where the object is. And N2 is 1. So U, that's about. We want that distance. You are told that the radius is 4 cm. That distance is 4 cm. This 1.5. So we have calculate that's our U. Right? The distance is our U. That's why we have to subtract. I want to find V. Right? That's your formula. Put in your value. N1 is 1.5. U is 2.5. 1 over V. Then 1.5 minus 1 over 4. So you get 2.11 cm. B. That's your where your V is. 2.1 cm to the left of X. Okay. Anything not clear?
Clear, Che?
This one is
No,
more.
no. Che, can you explain back again, Che?
Okay. Right, we are just using let's set up there. The formula. I said that our object is not here. Our object is here. Right? Somewhere here. Okay, so first write down your N1. N1 is here, 1.5. N2 is air is 1. Then you are told that this is 1.5 cm. So you want the object distance. That's the object distance. Right? Remember that's your pole there. So it's 4.5, 4.0, sorry. 4.0 is the radius. Minus 1.5, that's the object distance. That's what we get. You want to find V, and use this formula. Put in your value. N1 is 1.5. And then U is 2.5. It doesn't have to convert. This one, whatever unit you use, you will get the same answer as the same unit as what you use. N plus 1 over V, and 1.5 is N. We want positive this part. So 1.5 minus 1 divided by 4. Right? 4 is the radius of curvature at R, right? Then the others is just use your calculator. Okay with that? Which part is not clear? Okay,
Okay, okay.
Hemispherical glass block or radius R is a radius with center of curvature C. That's the center of curvature C, and reflective index 1.5 shown in the diagram below. An object O is placed at a distance R, that's your R, from the curved surface. The image formed by the curved surface is located at. Right? You want to find the image formed by this curved surface, not the whole thing. Remember that. You want this curved surface, not the whole head, not the whole glass block. Only this curved surface. Always read the question carefully. What's the answer? I tried to be too clever. I thought it was a whole glass block, so I got the wrong answer. Yep. Ken?
This one I don't know, sir.
Right, still very weak. Right, N1 is where we have the object. That's your N2. Right, N1 is 1. So that's your V. Right now, N1, N2, U. That is your U. Right, that's your object. So it's R. I want to find V. Use the formula there. In your value, N1 is 1. U is R. And N2 is 1.5. V. And this one, you just want positive. Just say the larger minus the smaller. Divide by. Right? And R is the radius of curvature. R. Then calculator. Now use your calculator, that's all. Image negative means it's virtual. And 3R to the right of the curve. That's your image distance. So you want the image formed by the curved surface at okay, image is virtual and 3R to the right of, right? That's your curved surface. So 3R is here. And 2R to the right of 0. Right? That's R. That's a 3R. So this is 2R. Right? So this one means you choose what is written here. The answer is A. Okay, no direct answer. They want you to do a bit of calculation. That's why it's a bit more challenging, STPM. Not like SPM. They have a direct answer. Yep, which part is not clear?
Clear, sir.
Okay, let's go to number 6 then. A converging lens produces an inverted image which is twice the size of the object when the object is at a distance 30 cm from the lens. what is the new distance of the object from the lens if the size of the newly formed image is about twice the size of the object? Okay, what's the answer? Right, write down all the thing that is given, the first part. Right, your U is 30 cm. Magnification, V over U. Right, want to find your V, take the U across there. Magnification, yeah, told is twice. There's 2U, 60 cm. And use the formula to find the focal length. And after that, work out again. No? Want to find U. Right, yeah, told that the new distance of the object from the lens if the size of the newly formed image is about twice the size of the object. Image distance of the object from the lens if the size of the newly formed image is twice the size of the object. Okay. Virtual image. Lens formula, put in your value. Right? Focal length we have calculated. 1 over U. It's a virtual image. Calculate out. 10 cm. Yep. Which part is not clear?
So why V equals to negative 2U?
Okay. You can see that both of them are the same thing, but you are told that the newly formed image is about twice the size of the object, so it cannot be inverted anymore. If it's inverted, then your object distance is 30 cm, but that's not answer here. So the only other way is possible is virtual image. Yep, if not, it will be exactly the same as the first one. So it cannot be. So you just have to guess that it's a virtual. Okay now.
Okay.
Same, they are exactly the same. These two are exactly the same. So it cannot be the original. There's no 30 cm here. So it must be a virtual. That's how I guess. Right? Nothing indicated here. What is the new image distance of the object from the lens if the size of the newly formed image is about twice, it's also twice the size of the object? How can it be? Right? This is twice, this is also twice. So it must be virtual. Okay, this one I didn't teach you. So I go over with you. Realize that it's required in the syllabus. Right? You're only doing passive paper, then you know what is required, what is not. The syllabus itself is very limited. Right? Long-sighted hypermetropia. With normal vision, the furthest point seen is a very long way from the eye. We call that infinity, very far away. This is called the far point of the normal eye. Okay, so there's a normal eye. That's your far point. We will focus on the retina. For normal eye, the nearest point seen distinctly by the normal eye is 25 cm. Right? The near point is here, 25 cm from the eye. This is called the near point of the eye. Sorry. long sight. For normal eye, the near point is 25 cm from the lens. That one you must know. Usually they will tell you lah. The object at the near point is focused on retina. Right? If that's the near point there, normal eye, no eye problem, the image will be formed in the retina. For a person with long sight, right? Long sight means he can see far away. Near object he cannot see. For a person with long sight, the object at 25 cm is focused behind the retina. That's the point. Right? Near point, focus behind the retina. How do we correct it? Object further from 25 cm is focused on the retina. Right? So any object further from the 25 cm will be focused on the retina. So that's our problem. So to correct for long sight, a suitable converging lens is needed. Right? Converging lens is needed. Okay. So near point becomes our object distance. We want to have a lens, right? That will make the virtual image, right? This near point appear at the point that we can see. Right? Virtual image at n dash. So that's your V. This is your U. This is your U. The ray from n are now refracted as if they enter the eye from the near point. So that's our new near point. Right? That's all we can see where we have a long sight. That's why, so the 25 cm, we use this lens so that it can be reflected from this near point, the eye that we can see. The near point is the object distance. Right? That near point, original normal eye near point is the object distance, while the near point, n dash, is a virtual image. Right? That's your virtual image here. So that is your image distance. So our object distance 25 cm. The image from the converging lens is virtual. Okay. So this one is taken from Nelson and Parker. The near point of a defective eye is 30 cm from the eye. If the normal near point is 25 cm from the eye, find the focal length and power of the lens needed to correct this defect. Okay, try and see whether you know how to answer this question.
I cannot larger.
Just went over with you. Just write down your 25 cm is the object distance. That defective is the image distance. Put a negative sign there. And use the equation. Put in your value. That one is minus 30. This one is 25. Calculate your focal length 150. You want power. Power, you have to change that to meter. Right? So it's 0.67 D. Okay, not? Anything not clear? Yep. What is not clear? Can or not?
Okay, sir.
Okay, then how to solve this question? This question? A person who has a long-sighted vision can see clearly when objects are at a distance 90 cm and beyond. For normal vision, object can be seen clearly at a distance as near as 25 cm. What is the focal length of the corrective lens that enables a person to have a normal vision? Yep. Ken? You still don't understand what I just teach you. Right? That's your object distance. The near point is your object distance. Yeah. The actual near point normal eye is the object distance. We put a lens there so that that object becomes virtual image at a distance of what we can see. Right? Here we cannot see. So we use a lens to correct it, that push that object to that image. That's all. So that's your V, a virtual image. So what's the answer? You cannot. Same as what we have done. U is 25. Image is minus 90. Put in your value in your lens formula. Right? That's your V. Right? That's your V. That's your U. Calculate out 34.6 cm. Donkey. Okay now.
Okay.
Okay, the other one is short sight, which I didn't teach you. That's for your normal eye. Right? Object. That's your object at infinity will be focused retina. That's another name for short sight, myopia. So if you have a problem with short sight, object at infinity is focused in front of your eye. Right? Your eyeball is too big. So it focus in front of the eye. So you need a convex lens to converge it, right? To diverge it, if you like, so that it focus at the focal length at the retina there. In normal eye, object at infinity falls on the retina. For short sight, object at infinity is focused in front of the retina. That's the case there. The furthest point is the furthest point is a distance x meter lah. That means you cannot see for very further from x, depend on the person. To correct for short sight, a suitable diverging lens is needed lah. So this one haven't come out yet. Also it come out. So object at infinity is reflected as if it comes from further point. So now, right, we have to put a lens there so that the object at infinity appear to come from the furthest point. So it means that our furthest point is our focal length of the diverging lens. Okay, try this question. The far point of a defective eye is 1.0 meter. What lens is needed to correct for this defect? Yep. Can or not? Can or not? Right? Diverging lens of focal length 1.0 meter is needed. That's all. With the lens at with this lens, at what distance from the eye is the near point? Right? So now we have to calculate where's the near point. Right? Using the lens rays from near object U. Right? Remember that is your object distance is reflected by the lens as if it comes from 25 cm away from the reflecting lens. So remember, it's a diverging lens. So the focal length is 100 cm minus 100 cm. Right? So we are looking at the object. So this becomes the image distance. And use a formula, that's all. And calculate out. Yep, can or not? So your near point is now 33.3 cm. Anything that's not clear?
Clear, sir.
Anyway, you can review that yourself when you're free. Right? Yes, the weather has come out or not, I'm not sure about 2020 onwards, I'm not sure. But before that, it has not come out yet, so it's possible it can come out anytime. Okay, try this question. What's the answer? An object, sorry, everything is an object at a distance, that's the object, distance xm in front of the thin Pinot convex lens, so that the image is formed at an equal distance as your image form, distance x is shown in the diagram below. If the refractive index of the lens is 1.5, radius of curvature of the surface is 20 cm, what is the value of x? Okay, what's the answer? Can or not?
Donkey, sir.
Okay.
You use the lens maker formula.
Okay, write down what you want. Radius for this curvature, 20 cm. Given there. And then N1 is the air, right? You're supposed to know. And then N2 is a plus. And R2, that part there. Right? Flat means the radius of curvature is infinity. And use the lens formula. Put in your value to find your focal length. N2 is 1.5. R1 is 20 cm. R2 is infinity, and then calculate out 40 cm. And after that, use your formula that you calculate. Right? Your U is X, your V is also X, both are real. And put in there, calculate your okay. So answer is boy, good. How about this one?
Lens maker formula also, sir. So the answer is C.
What is the answer?
Hello, sir.
What's the answer?
C.
Ah,
C.
C. Sorry, my mouse ran out of
Battery.
yeah. Don't know why it suddenly stopped. Have to use a new mouse.
Is it a wireless one or wired one, sir?
Wireless.
Then you have to change battery lah.
Yeah. Okay. I have an idea or sketch to help you understand what is happening. Right? Same as the previous question. R1 is 40 cm. Right? That's your R1. Sorry. That's your R1. And N2 is your N2. N2 is this one. N1 is the air. And R2 is infinity. Same as previous question. Then use the length formula, calculate out. Okay, donkey, good. Let's go to number 10. Okay. Comparing section B and section C. It doesn't look like every year it comes out. Sorry. It doesn't look like every year it comes out. 2018 and 2019 didn't come out. So when it comes out, usually they try to cover all the topics. Right? That's how we set exam paper. You want to focus on one subsection. You try to cover all of them if you can. Right? This one is a bit tougher lah. But you have to show your ray diagram. Okay. So I also burning lah because I get a different answer. Right? It's not easy. So the first part, the dimension of the object is 3 unit, 5 unit, 3 unit. And F is the focal point of the concave mirror. Draw a diagram to locate A dash, B dash, C dash, D dash of the image, which correspond to points A, B, C of the object. State the characteristics of the image. Image is real, inverted, I would say distorted also, because it's not the same as right? It's not completely enlarged. So I don't know what you get. It's not easy to draw, but can you get the answer?
No, sir.
I don't know how the examiner is going to mark lah. Right? Because
I hope this kind of question don't come out lah. Sir.
Say again.
I hope this kind of question don't come out lah. Sir.
That's why I say he will have headache. How? It's very complicated how to draw.
Possible skip the chapter lah. Sir.
Simple one, okay. Simple one can draw, but this one you must know how to draw. Right? First
Yeah,
part.
it's safer to skip lah. Safer to skip.
Better don't skip. Everything must learn how to do.
No, do the other chapter lah. Sir.
Draw at least one side, oh. Cannot draw the other side, draw one side. Right? There is your parallel. After reflection, it comes from it passes through the focal length. Then this one go from the object, pass through the focal length. After that, it comes parallel. So that is your C dash. Right? That's your C dash. Same thing. Right? D is from here. Come out to here. And after that, reflected parallel. Right? You must know how to draw ray diagram. That's important. Right? Whether they give you a full mark is up to them. But 2 mark only lah. This one. And right? This one is still the same. Parallel. Right? D is also still parallel after go focal length. So you have to, a bit harder to see unless you can use different color lah. So that's your D. So that one there. The one there is here, somewhere here. Then after that, count the number of square. Right? So mine is different answer because I also get different from the book. Area is 3 times 5. That's the number of square, small square. Then the object is 15, small square. Image is 8 and 8. As long as you show the answer, they will give you some marks there. They not give you the full mark. Okay, let's go to the next one. Section C. An object is placed 30 cm in front of the converging lens with focal length 10.55. Sketch the ray diagram of the image. You should be able to do that. Right? That's your focus. That's double the focal length. Right? So this 30 cm is about 4 times. So roughly give you about 4 times. And parallel, ask your focal principal focus. Then this one, go to the optical center directly and draw. Right? It should be invert and calculate the position of the image. That's all you require to do. Part 1. Right? Object 30 cm, focal length 7.5. Use the lens formula. Put in your value 10 cm. You should already know it shouldn't be more than twice the focal length, because this is more than twice the focal length. It should be smaller. V should be smaller. And determine the magnification. Magnification is object distance divided by your image distance. State the characteristic of the image. After you have calculated, is inverted, real, and diminished. And anything not clear? Ask whatever is not clear.
Yeah, I think I'm okay, lah.
Okay,
Go back again. Inverted. Oh yeah, makes sense lah. Inverted, real, and it's not a virtual image. It's
you
a
can
real
see
image.
from your drawing, you can see it's inverted.
Yeah, diminish is because it's becoming smaller. So
it's more
yeah.
than twice the focal length. They should be diminished. Real.
Teacher, but this one now no need to memorize, right? Understand and draw better.
Understand.
Right,
understand. Wherever the image is here, it is real and it's always inverted. Then whether it's diminished or whether it's magnified, depend on your object distance.
Okay.
So if the object is at 2f, then the image is at 2f. That's a standard one, same distance, same size. So this one you should know already. More than twice the object distance. So the image must be diminished.
Automatic, yeah.
You need to remember your basic .
Okay.
A 10 cm tall object is placed 15 cm in front of the convex mirror. The radius of curvature 40 cm. Calculate the position of the image. So what is your answer? What's your U? Yep, what's your U? Write down what is required. What's your U? This is your STPM work. Right? U is, right? Understand your picture. That's roughly your picture. So straight away, it's a convex mirror. It must always be upright, diminished. So object is 15 cm. Radius of curvature is 40. So the focal length is 40 divided by 2 is 20 cm. Right? Negative because it's a convex mirror. Put in your lens formula, put in your value, and then use your calculator. Minus 8.5. Right? So it's behind this mirror. Right? You have to explain why you get negative sign. Height of the object. How to calculate the height of the object? Yep. You are not ready yet. Didn't do your homework. Why a magnification? No? Right? Object distance over image distance. Right? That's object distance. There's your, sorry, there's the image distance. Object distance is there, that one there. So after calculated, no need to worry about negative sign there. Right? Magnification equals to your object. Okay, what have I done? Oh, sorry, correct. You want to compare the image, the ratio of image to object. Right? Magnification is image height over object height. That's why you take the object height to the other side, put in your value. There's your magnification. There's your 10 cm. Right? There's your 10 cm. Calculate out. Okay. Anything that is not clear?
Yeah.
A spider, sorry, intend to get a spider with diameter 2 cm hangs from the ceiling. Distance between the spider and the wall is 200 cm. A thin lens is placed so that the image on the wall is
Convex lens.
say again.
Convex lens.
State the type. Okay. Determine the position of the lens of the wall. Can do. Basically, we have done your exercise in your revision book. It's actually done there already. It already came out already. I have a picture. What is the answer? I have a picture. The image is on the wall, so the wall is here. There's your spider. There's your lens. There's your focal length. Know how to sketch also. This one roughly show you how to sketch. Right, so there's your wall. That distance is 200 cm. There's your spider. Converging lens, correct. Let the image distance be V. Right, that distance be V. Because you want to calculate, determine the position of the lens from the wall. Right, you want to calculate that distance there. V. That's your V. Sorry. Forgotten to change the got in for the internet. That's your V. That's your U. That's all.
Teacher, converging lens means it's convex lens, right?
Converging is convex, yeah, you're right.
Okay.
You want to find V. So we let the distance be the length from the wall, let it be V. Then we are given is 200 cm, then U is just 200 minus V. And use the magnification. You are given the thin lens is placed so that the image formed on the wall is half the size. Right? That one is magnification. So V over U is half. Right? So U take it up, M down. So V half, M is half. So U is right, times 2 here, times 2 there. We got 2V. and use the length formula. Right? Cannot have two unknowns, so I have to replace a u, that u there, with 2v. No need to use the length formula. This one is used magnification formula. And from there, I can calculate your v. Okay. Ken, which part is not clear? Yep. What is not clear?
When u equals to 2v, is it?
Say again.
U equals to 2v, is it?
Yep, from here, use a magnification formula. You are told that your magnification is half. That's why we write half here. So it times 2 denominator,
2v
times 2 numerator. That becomes 2v. Then after that, put into your original formula. Here, you got 2u. U is 2v. Put it here. Take the v across there. So 3v equals 200. So v is 200 divided by 3. Yep. Which one is not clear? You are still very weak.
Clear, can go on. Teacher, I remember that day the chapter 3, one of it we missed already because I was too tired.
Say again.
The chapter 3.
Yeah.
Sorry, chapter 21.
Yeah.
One of the essay like uncompleted, I remember.
Yeah. We haven't completed. We see we got time. We will go over that.
Okay.
Okay. Let's go to the. I think this is the last one, if I'm not mistaken. An object of height.
Yeah, that's the last one.
5 millimeter is placed 35 cm from the vertex of a spherical surface of a glass rod. An image is formed inside the rod 50 cm from the vertex of the glass rod. Reflective index 1.5. State 2 characteristics of the image. So it looks like this is, right? You should be able to tell real and inverted. This is more like a convex spherical mirror. Right? You got a vertex. So it's real and inverted. Determine the radius of curvature of the spherical surface of the glass rod. Okay, use the length formula. N1 is for air. Remember, the object is in air. And you are told that object is height 5 millimeter and place 35 cm. That's a U. Image is formed inside the rod, 50 cm. Okay, so you need to have an idea. Right? Either you draw it or you have an idea. Right? That's your glass rod here. This is your glass rod. There's a surface there. This is your N1, this is your N2. Right? There's a U, there's a V. Okay, then calculate your radius of curvature. Sketch a ray diagram to show the formation of the image. Right? There's your glass rod. Right? The ray that goes to the radius of curvature will go straight through. The ray that comes down from here I remember this tensor. Your normal is here. So instead of it going straight through or to the left, it must go to the right. So where the two cross, that's your image. Yeah, it's very challenging for me also. That one I have to also use the internet to help me. Forgotten to know how to apply what I teach you also. Ken, anything not clear?
Okay, sir.
This is your normal lah. So instead of it going straight through, it reflects towards the normal. Whereas this one from the top there will go straight to the radius of curvature C. Determine the position of the object if the virtual image is 10 cm from the vertex of the glass rod. Okay. Right now, what is required? What is given? Right, I told virtual image. So you put minus 10 cm. Radius is that. So use your lens formula again. Put in your value. This is your air. Air is 1. U is what you want to find. N2 is 1.5. V is minus 10. That's your V. Then is 1.5 minus 1 over radius. This is that. And use your calculator. Okay, with that. Any comment? Anything not clear?
Okay, sir.
Yeah.
Okay.
A thin by convex lens with radius of curvature 10 cm, which is immersed in a liquid or reflective index 1.65, is shown in the diagram below. Reflective index of the lens is 1.5. I remember I vaguely, when I was your age, I'm struggling with this one. Don't know how to solve it. Now teaching you, I have to learn to solve it. The reflective index of the lens is 1.5. Determine the focal length of the lens. Okay. How to do that? Yep. How to calculate that? Can give you some hint. Right down. This is 1.5, N1. That one is N2 by convex lens. Reflective index 1.5. Right? Use the lens formula. Okay. Put in your value and calculate out. I'll give you some hint already, so now you should be able to tell me the answer. Ken, what's the answer? N2 is 1.5. N1 is 1.65. R1 and R2 is the same. Each of them 10 cm. So what is the focal length? Okay, Srini, what is the answer? I've given you all the hints already, so you should be able to calculate for me the focal length. Okay.
Negative 55.
Okay, good. Negative 55. So what does it tell you?
So negative 55 because it's convex, right, sir?
I also have to readjust my, no. Negative means it's a concave or
Sorry,
diverging.
concave.
Diverging. When I get negative, it must be. So you should be able to draw, sketch a ray diagram to show the position of focal length. Right? It's diverging. So produce it backward. Diverging lens. So that's your principal focus there. Can or not?
Okay.
Write down the lens makers.
1 over f equals to bracket n2 over n1 minus 1, and then close bracket, and then another bracket 1 over r1 plus 1 over r2.
Remember, it's 2 mark. You just write formula there. It's only 1 mark only. You have to tell the examiner what does each of the term means.
Oh, like that?
Of course. You cannot expect them to understand.
Thank you for telling me that, sir.
You have to tell them, even if
So
they
F
didn't tell
stands
you.
for the focal length.
N
is the refractive index. R is the image distance, whatever.
Right? N2 is the refractive index of the lens. R1 and R2 are the radii or curvature of the lens.
Radii.
Then determine the radius and shape of the other surface of the lens.
Determine the focal length. You can take from the power lah. It's a 1 over 4, so you will get 0.25.
All right, remember this in meter.
Meter.
Then radius of curvature.
Radius of curvature, with all the clue given, n equals to 1.56. Yeah.
Okay.
And then can
your
find
value.
Yeah, that's all.
Calculate it out. Okay.
And then they say determine the shape some more.
R2 is convex. You get a positive answer.
Because it's positive.
I tend to disagree from your answer from your book. Right? That's why I put a different color here.
Oh, that's the meaning. Okay.
Explain the change in power of the lens if it is immersed in seawater with refractive index that is higher than that of glass. So same like the previous question, no? Right? You use the lens formula again. That's why I argue out from there. No? Right? Remember your N2 is less than 1. N2 or N1 is less than 1. Remember you are told the seawater with refractive index that's higher than glass. Right? So N1 is not larger. N1 is the seawater. N2 is that of glass. So this is going to be less than 1. So this is going to be negative. Focal length is negative. The power is negative. The lens become a diverging lens. So that's how you argue it out. Can? Oops, sorry. Okay or not? Which part is not clear? Okay, Right, this one I also didn't teach you, so you have to review from your SPM. No? The microscope. This one I didn't teach you, so I expect you to review it from your SPM. Same like your telescope. Okay, this is your compound microscope. A microscope that consists of the objective. There's the objective lens. There's your eyepiece. Is shown in the diagram below. The focal length of the objective lens is given to you, written for you. And then for the objective is 30 cm. The lens is 56.5 cm apart. That distance is given you. A sample of microorganism is placed 30 millimeter from the objective lens. Determine the position of the final image form. Can? Write down what is given. Can or not? What is a U?
Okay.
What is a U?
30.
U is what?
30.
No. U is here. U is here. Oh, sorry, you're right. I go and focus the wrong thing. Sorry, you're right. U is 30. Focal length. Start with objective first. Work with the objective one by one. No need to memorize formula. Work with the objective. Right? Image of the objective. Okay. Use the formula. Focal length is 15. U is 30. Then calculate your V. Right? There's your image here. Object is here. There's your object. There's your image here. Roughly sketch lah, so they can sketch on the diagram itself, so that you know how it is. Right? It should be inverted. It should be magnified also. That's what we want. Calculate out. V is 30. So that is your 30. Right? Now this becomes the object for this eyepiece. Right? Look at the image of the eyepiece. Okay, the image distance. Remember, we are looking at this eyepiece there. Now this becomes the object. So this becomes the object distance. Okay, so 36.5 minus 30, you get 26.5. Okay, focal length is 30. They can work with the same unit, all in millimeter, it doesn't matter. Or can work in cm, whichever you prefer. Then calculate out your V minus. Right, it should be minus. So it means that the image is here. Can? Then calculate your magnification. Right? Magnification, remember we are calculating it, compare the final image with the initial object. So the final image is 22 cm. Right? Explain why the negative sign there. 227 millimeter to the left of the eyepiece. Yeah, not here, not to the right. Okay, explain the negative sign there. That's important. Magnification. Okay, you are told that that's the first one. Magnification 30 over 30. Your object distance is 30. The image distance is also 30. So that's the first one. And the next one is image is 227. Right? Object distance is that one there. And calculate out. Can or not? Anything which is not clear?
Clear.
Okay, let's look at 21.
It's the last one, right?
I think so. Then we call it a day. Have you decided which day you want your next class?
Tomorrow,
What time?
3:30.
3:30. Okay.
Actually, 3 o'clock better lah. 3 o'clock.
3 o'clock. Okay.
Sorry. 3:15. Sorry, 3:15.
I think we just take about a few minutes break lah, to let you go to the toilet if you want to, or have a drink.
When?
No,
Tomorrow I got school.
Now. Take a few minutes break. Okay.
Okay, then don't stop the class lah. Just leave it.
I won't stop. I just let you go for a short while, then you come back.
Only one essay question, what? Can finish
Yeah,
fast.
you do the essay question. So I will just take a short while. Then I will come back.
Okay.
Okay, Srini, are you back? Are you back, Srini?
Give me 1 minute, sir.
Okay. I drink too much water, that's why I have to clear my bladder.
Okay, sir.
Okay, I think we have done this part already. Always remember, you cannot write formula alone. Right? You
So I
must,
can't see your slide.
can't see my slide. Okay. Sorry. Cháu xanh. Can see now?
Can, sir?
Okay. Let's carry on then. Right? Remember, your definition, you can write in formula form, but you must tell the examiner what does the symbol stand for. We already say that already. That is okay. So I know you have to tell them. Threshold of hearing. Right? And then what is beta? Beta is the sound intensity level. Okay. An audio system produce sound intensity of level 80 dB at a distance of 55 meters. Determine the intensity of sound at that distance. Right? They ask you to define, they want you to use a formula. Sound intensity level, that's what they want. They define it, use a formula, 80, 10, and we don't have the distance, but we got I. That one is given. Then calculate our I. After you calculate your I, use the other formula. Right? We already calculated there, your I. Calculate the intensity level of sound level at a distance 100 meters. Okay, we are just using this formula. Sorry to simplify. Right? That's our definition. We are using this formula. Power is still the same. Distance change only, so I take my R squared over. These are P and 4 pi is a constant. Right? This is the formula I use. Or maybe I will take it down. Take a copy of it. Take a copy of it. Okay, I'm just using this formula. Take the R square to the other side. That's why I get all the constant to one side. You can use this formula to calculate if you want to. But as I say, unnecessary calculation. It's nothing wrong. Right? I prefer getting all the constant and rather than cancelling again. Right? So I2, R2 square, I1, R1 square. I want to find your intensity, I2. So calculating again. Right? Take my R2 down. That's what my equation get. And put in your formula. Initially, R1 is 55. R2 is 100. And I1, that's your I1. Calculate out. Then use the formula to calculate back again. Okay, that's your I2. Right? This I0 I know is given you. That's I know. Okay. Anything that's not clear? Can or not finish? Which part is
Can continue.
okay? Almost finished. I can see Doppler effect is quite popular.
Very popular.
Yeah, yeah. A bird is flying towards a bird watcher while emitting sound of frequency 1275 Hertz. The bird watcher hears a sound of 1350 Hertz. Determine the speed of the bird. Yep. What formula should I use?
Oh, you need to determine which one is the sound and the observer first. So in this case, the observer is the
So what is your V naught?
observer is the bird watcher. So
Observer is the
right,
bird.
or not the bird watcher, Acha.
The observer is the bird watcher.
Oh, yeah.
So the bird watcher is not
sound,
moving.
the source of the sound is from the bird watcher.
So what is your V naught?
V naught is the bird. 1275.
V naught.
Yeah lah, 1275. Oh, V naught. V naught is 0 lah.
VS?
VS is 343.
VS is 343. VS is what you want to find. V is 343. That you must know. Okay.
Okay.
Put in your value. This is your F naught. This is your F naught. This is your F. Right? That's your V. And calculate your VS.
Okay.
Explain why there's a difference in frequency heard by the bird watcher. Right? I tend to disagree with the answer in your book. Because he used more calculation. You can use that like you want to, you prefer calculation. But I prefer to use to just imagine this diagram. No? This diagram. Right? Where there's your bird, there's your observer. So as the bird or the police car is moving towards the observer, right? The source is moving towards that. So the wavefront is closer. So wavefront is closer means the wavelength is shorter, right? Smaller wavelength. Small wavelength means higher frequency. Right? So when the bird is moving towards the observer and emitting sound, the bird watcher sees the wavefront closer together. Frequency is the number of wavefront observed per second will be larger. Right? The wavelength will be smaller. That's how I will explain it. Then beat. If the bird sits on a near, if another bird sits on the tree near the bird watcher and chips 1270 Hertz, calculate the beat frequency heard by the, that one is just a memorizing formula. Okay. Hey, what did I do? It should be 170, 1270, sorry, 1270. Okay, now. Yep. Any question?
No, Chuck, that's all I can understand. Beat frequency means is the highest minus lowest lah. That's it.
Yeah, it's always positive value.
Okay.
Are you sure tomorrow
Yeah,
you are
that's all lah,
ready,
Chuck.
ready for the next topic? Are you sure tomorrow you are ready for the next topic?
Or Wednesday lah, Chuck. Wednesday better.
Well, you better think properly. If you don't have, then it's better to have it on Friday. You better think properly. Can contact me.
No, but then like cannot cover one chapter, what, Chuck?
Two more topic already. 2 more topic left.
No, 3 more.
3 more. Oh yeah, 3 more topic. Anyway, you decide. You have to do your homework first. If not, it's a waste of time. I'm doing all the homework for you. You don't learn anything. Okay, we'll stop here. Anything else you want to clarify?
No, Chuck.
So how is your second term work?
Not sure do yet.
Better start having some time for your second term work. There's a lot to cover.
Okay, Chuck.
Okay, if there's nothing to ask, we will stop here.
Yeah. Okay, thank you, Chuck.
Okay, bye-bye.
Bye-bye.